Assalamualaikum and selamat sejahtera. Okay, we continue with the second lesson for 4.1 thermal equilibrium. So the standard of our standard learning is to calibrate a liquid in glass thermometer using two fixed points. Okay. Okay. Let's look at conversation between two students. Okay. The boy said this thermometer does not have a clear scale, so we need another thermometer. But the girl said this thermometer can still be used. We just need to calibrate the thermometer. So a thermometer that does not have a scale can be calibrated using two fixed temperature points. First question, state what happens to the liquid in the capillary tube of thermometer when it is absorbed. So the liquid will expand. What does the length of the liquid column in the capillary tube indicates? Indicates the magnitude of the temperature. So the higher the liquid expand means that the temperature increase. Okay, first point. So calibration is a process of making a scale of reading on a thermometer. Okay, so we want to for example, the length between 1 degree Celsius to 2 degree Celsius, how long? Okay, so that is the calibration. Okay, how we do the calibration? So we have what we call two fixed point. So the first one is 0 degree Celsius, the fixed lower limit, that is the melting point for ice. Another one is the 100 degrees Celsius, the fixed upper limit, that is the boiling point of water. Now, the length of liquid column between the fixed lower limit and the fixed upper limit is divided into 100 equal division, because from 0 degrees Celsius to 100 degrees Celsius. And the thermometer is then calibrated and can be used to measure temperature between 0 degrees Celsius and 100 degrees Celsius. For example, the length between 0 degrees Celsius to 100 degrees Celsius is, let's say, 10 cm. Then we divide it by 100 degrees Celsius section, and one section is equivalent to 0.01 centimeter. Okay. Now, the process of calibrating uses the thermometric property of liquids in glass. So, thermometric property means a physical property which can be measured which change with temperature. For example, length of column of liquid expand when temperature increase. Okay. So, how a thermometer is calibrated? So, at the scale of degrees Celsius, two fixed temperatures are chosen. Again, we discussed just now. Lower point or ice point is the melting point of pure ice, that is 0 degrees Celsius. Second one is upper point or steam point, that is the boiling point of water at atmospheric pressure of 1 atmosphere. That is what? 100 degrees Celsius. Okay, so this is the instrument that we use to determine the ice point and also the steam point. Okay, so let's discuss in detail. So the first one, we have a beaker A. Okay, so the aim of our activity is to calibrate a liquid in glass thermometer using boiling point of distilled water and melting point of ice. So the apparatus. Okay, so the first one, we cover the scale of thermometer with masking tape so that the scale cannot be seen. So we will use ordinary thermometer with the scale. So we put the masking tape so we cannot see the scale. Now, the first one, we fill beaker A. So this is beaker A with ice and a small amount of distilled water. And then we put the thermometer into beaker A. Wait until there is no more change in the level of liquid column. So the temperature will rise up, right? So wait until it stop increase, and then what we do is we mark the level of liquid column on the stem of the thermometer and label this as 0 degrees Celsius, right? Okay, so we label it as 0 degrees Celsius. Now the next one, we put another beaker B with distilled water, and we heat up with immersion heater. So fill beaker B with distilled water and put in an immersion heater. So, and then we put the thermometer. So when the distilled water in beaker B is boiling, put the thermometer in beaker B. Wait until there is no more change in the level of liquid column. Next, we mark the level of liquid column on the stem of the thermometer. This level is known as 100 degrees Celsius. After that, we switch off the immersion heater, right? So now we have two levels. The first one is 0 degrees Celsius. The second one is 100 degrees Celsius. Alright, so we have like this level. So 0 degrees Celsius is the bottom point. 1 degree Celsius is the upper point, right? So what we do next is measure the length of 0 degrees Celsius to 100 degrees Celsius, and we mark it as L100. For example, 100 degrees, 10 cm, right? Prepare beaker C. We have another beaker, and then we fill it with tap water with unknown temperature. So we put the calibrated thermometer into beaker C, and again we wait until there is no more change in the level of the liquid column. Then mark the level of the liquid column on the stem of the thermometer and label this level as theta degrees Celsius. Next, we measure the length of from the 0 degree Celsius mark to the next, we calculate the temperature of tap water using the formula theta equals to L theta over L100 times 100 degrees Celsius. So this is how we get the unknown temperature, right? Now, let us discuss a few questions. So question number 1, the bulb of the thermometer should not touch the base or side wall of the beaker while taking measurement. I explain. Because we want to prevent heat loss through the beaker to the surroundings. Number 2, why should you wait until there is no more change in the level of the liquid column before making a mark on the stem of the thermometer? Because we want to make sure that the thermal equilibrium state is reached. It means that no more increase of the temperature. Right, so this is how we get the length. So the first one, we have theta is the temperature of the liquid, unknown temperature. L theta is from here, the length of the capillary tube at temperature theta. L0 is the length of the capillary tube at ice point. So this one, from here to here, ice point. And L100, length of the capillary at boiling point. So from here to here, 100 degrees Celsius. So what we do is, we have the formula T equals to L theta minus L0 over L100 minus L0 times 100 degrees Celsius. So let's try to do one question. Now, what is the value of temperature T? So from here to here, this is L0, right? 3.6 cm. From here to here, 13.6 cm is L100. And 9.3 cm equivalent to the L theta, unknown temperature, right? So what we do is, we use that at 0 degrees Celsius, the length is 3.6 cm. At 100 degrees Celsius is 13.6 minus 3.6 equals to 10.0 cm. So x equals to 9.3, right? 9.3 minus 3.6, we got 5.7. Then we do mathematics. So x equivalent, x divided by 100 degrees Celsius. 5.7 cm divided by 10.0 cm, and we get x equal to 57 degrees Celsius. Or we can use the formula that we used just now. So the formula will x equals to 9.3 minus 3.6, right? 9.3 minus 3.6. 13.6 minus 3.6, and we got 57 degrees Celsius. Okay, same, right? Okay, so that's it for our topic. So let's discuss the formative practice 4.1 on page 124. Okay, first question, state what happens to the two objects in thermal equilibrium. So final temperature of both objects are equal, right? Another one, heat is transferred from object A to object B, and also from object B to object A with the same rate, and the net heat transfer is 0. Okay, first question. The second question, is our body in thermal equilibrium with the environment? Explain your answer. Okay. Alright, do you think yes or no? Yeah, the answer is no. Because the human body runs at a constant 37 degrees Celsius, but the air around you at room temperature is about 20 to 25 degrees Celsius. This means heat is constantly leaving your body to warm your surroundings. So our body constantly utilize energy that is obtained from food that we have eaten. So in producing heat that keep us warm. Only several hours after death will your body approach room temperature. At that moment, we have we are in thermal equilibrium with the environment. Okay, last question, number 3. We have the diagram. So I shall use an uncalibrated laboratory thermometer to determine the temperature of a liquid theta degrees Celsius, right? She finds that the length of the liquid column when the thermometer is put in the liquid is shown. So calculate theta. So what we have here is the top one, 4 cm. The 0 to 100 is 12 cm. So what you do is 4 divided by 12 times 100, and the answer is 33.33 degrees Celsius. Okay, so that's it for today. So we stop here. Thank you. Assalamualaikum and selamat sejahtera.